Okay, in a perfect world, we wouldn't really need to worry about imperial measurement, but because the states uses the imperial system, we have to know what it is and how to convert it into SI measurement. Okay, so the imperial system is based it's from England from hundreds of years ago, and it was based on the measurements of a king. So a foot was the king's foot, and then a yard was 3 feet. So it's not very exact, but it's what the US still uses. So here we have inches, okay, inches, or the 2 little lines. Okay, so you often see people's height as, 5 feet, 10 inches, and so there's foot or feet, and it's a 1 line. Then you have yard and mile. Okay, so in standard, in SI units, this would be centimeters. We don't really have a foot one, and then essentially meters and kilometers. Now, they're not an exact conversion, but those are the approximate values that we have. And so your data pages will show that the conversion factors between imperial units are 1 foot for every has 12 inches, and 1 yard has 3 feet or 36 inches. Okay, and this is just like how we know that 1 meter has 100 centimeters. Okay, so to convert imperial unit conversions, we have to use unit analysis. Okay, so this is no. So inches and yards. So we want inches. We have 7.5 yards. And we know that there are 36 inches per 1 yard. Okay, so then if we do our math and our yards cancel out, so we times 7.5 times 36 inches, and we get that there are 270 inches in 7.5 yards. Okay, and again, yards are bigger than inches, so it makes sense that we need lots of inches to fill up a yard. And then to use proportional reasoning, remember proportional reasoning was like the cross multiply. So we have to look, first of all, at your data booklet for the conversion factor between feet and miles. And you'll see that 1 mile equals 5,280 feet. Okay, so we'll set up 2 equal ratios. So you have x feet, because we're looking how many feet are in 40 miles. And we know that there are 5,280 feet per 1 mile. We'll cross multiply, and hopefully since you're writing smaller you'll have more room than I do. And so you have x feet times 1 equals 5,280 feet times 40 miles. So you'll get x equals 211,200 feet. And again, miles are bigger than feet, so we can predict that we'll need lots of feet to fit in a mile. And we get over 200,000 feet in 40 miles, and so that makes sense. So measuring instruments, just like with SI, when we had rulers and meter sticks, measuring tapes, calipers, of course, when you're in the States, of course, you can measure things the same way. So they have their own measuring instruments. And so their rulers and measuring tape will look the same as ours, except instead of measuring to the nearest millimeter or centimeter, they measure to 1/16 of an inch. Okay, and if you ever spend any time in Home Depot or around building or watch home improvement shows, lots of things are in imperial, like 3/4 of an inch or 5/16 of an inch, just because the US is such a big power in the world, and so lots of manufacturing comes through there. And then their caliper can measure to the nearest 1/1000th of an inch. So how to read your imperial ruler. And most rulers here in Canada have both imperial and SI on it. So a lot of the times you'll have a ruler with inches and centimeters. So notice on your ruler here, there are a total of 4 big divisions between each inch. And then there are 16 small divisions. Okay, so you have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, and you have 4 bigger ones. Okay, so they divide there. So 1, 2, 3, 4. Okay, and that's because we divide into 1/16 of an inch, so we have to divide it into 16. And this is where SI is considered to be a little bit neater, because remember SI is in multiples of 10. Okay, and 10 is just a little bit easier to figure out, a little bit easier to ballpark. Okay, so here's your 4 divisions, 1, 2, 3, 4. This is 1 inch. Okay, so same here. This is 1 inch and 1 inch. Okay, and then halfway here is 8/16 of an inch, or, and I'll put it over here, a 1/2 inch, right? Because 8 divided by 16 is 1/2. Okay, so every little area from here, the little divisions, are 1/8 of an inch. Okay, and then when you go down, see how there's slightly longer lines? So you have the longest line in the middle, you have these slightly longer lines. Between here is 1/4 of an inch. Okay, so between the medium lines, there's 1/4 of an inch. So here's 1/4 of an inch, and then this would be your 1/2 inch, and here would be 3/4 of an inch. And tiny little one, the smallest line in there is 1/16. Okay, so it's still very logical. It's still broken down into small parts, but it just isn't as nice and clean as 10. Okay, 16 just makes you think a little bit harder. So now you try. If I ask you to measure from here to this point here, what is that? So first you'll have 1 inch, right? 1 inch. And then let's count how many there are here. So 1, 2, 3, 4, 5, 6, 7, 8. So that's 8/16. Okay, so you have 1 and 8/16 of an inch. And 8/16, if we reduce that, we actually get 1. That should be a 1. 1 and 1/2 of an inch, or 1 and 1/2 inches. And if you want, you could say 1.5 inches. Either one is fine. In the hardware store, you'll always see it given as this 1/2 or any fraction. But if you want to write the decimal, that's fine. So then how about here? So if I'm measuring from this point, how far is that? So we'll look, 1 plus 2 inches, so we have 2 inches, and then 1, 2, 3, 4. 2 and 4/16 inches. And if we simplify that, we can write 2 and 1/4 inches. Okay? Or in decimal, this would be 2.25 inches. because 1/4 is 0.25. Just like a quarter in money is 1/4 of a dollar, because 4 quarters make up a dollar. And then last one, let's try this one. Okay, so again, we'll start. We have our 1. We have 1 inch. And then, how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. So 1 and 10/16 of an inch. Now let's reduce 10/16. What can we reduce 10/16 to? Well, we can divide both by 2, and that gives us 5/8. So we have 1 and 5/8 of an inch. Or if you want to do this on your calculator to get a decimal, be 1.625. Okay, so if you look in your textbook, and you don't need to look at it right now, basically it's just a picture of a muskox. Okay, you can Google a muskox if you don't know what that is. It's a pretty cool, weird looking animal. So if the photo uses a scale of 1 to 30, find the height of the muskox in feet and inches. Okay, so our scale factor is 30. Okay? And so then remember that scale factor equals real over image. So then real, if we rearrange that, will equal scale factor times image. And in this case, the image is this photo. So if we measure the height of the photo in inches, okay, and I'll have you do this when you come into class, but since you don't have the textbook right now, I will just let you know that the photo is 2 1/4 inches high, or in decimal 2.25 inches. Okay, so it's 2.25 inches. So what is it in real life? So real equals scale factor 30 times image 2.25, and then we get 67.5 inches. And then to clean this up, we'll find out how many, we'll give it in feet and inches, just like your height. Okay, so we have 67, so we want to know number of feet. That's what we want. We know 67.5 inches. If you look at your conversions, you know that in every foot there are 12 inches. So 67.5 divided by 12 to cross off our inches, and we will get 5.625 feet. Okay, but we're not quite done because we were asked to give an answer in inches, feet and inches. So far, we'll put our answer over here. We have 5 feet. Okay? But then what about this part, this 0.625? Now we just have to go back to inches, so it's good conversion practice. So we want inches, so we have 0, and we have 0.625 feet. We know that there are 12 inches in every foot, so 0.625 multiplied by 12 is 7.5 inches. So we have 6 feet and 7.5 inches. Okay, find the distance between the tips of its horns in feet and inches. So again, in the photo, the distance between the horns is 1 1/1/16 of an inch. And in decimal, this is 1.0625 inches. Okay, and we still know that our scale factor from before is 30, and we can use this equation again. Okay, so we can just go right to the real equals scale factor times image. Okay, so our scale factor is 30. Our image is 1.0625. That gives us 31.875 inches. When you're doing something like this, keep as many decimal points as you can until we have a final answer. So then we want feet. Okay, so we want feet. We have 31.875 inches. In 1 foot, there are how many inches? 12 inches. So we end up with 2.65625 feet. So we have our answer, we'll put it here, and we have 2 feet. And then we have to take this decimal and make it into inches. So if we want inches, we have 0.625 equals 0.65625 feet times 12 inches per 1 foot. And we end up with 7.875. And we can round this up to 8 inches. Because then now we're at the end. So it's about 2 feet, 8 inches. Okay, so that is the distance between the tips of the musk ox. And then another example, see page 28. Again, it's another photo. Alishan wants to make a drum using a circular frame and caribou skin that he will stretch over the frame. He will then lash it into place along the frame with sinew. Alishan uses 3.5 inches of sinew for each inch of the frame. Estimate the diameter of the drum frame in imperial units. The scale of the photo is 1/115th. So when we estimate, we're just going to look at the photo. Okay, and if it's 1/115th, and we'll look at the diameter of the photo, and if the diameter is about this big, okay, so how many inches is that? Let me just draw that again. Okay, and this is what it would look like in the photo. So if you look at that little circle, what would you say that is? It's about, so D for diameter is about 1 inch in the photo. Okay, now actual diameter, remember we want real life equals scale factor times image. So scale factor is 15. 15 times 1. So our diameter is about 15 inches. And the squiggly equal sign, like this, means approximately. So now, approximately what length of sinew does he need? State your answer in yards and inches. So this is just like that barrel question we saw in the last unit. I make this a little bit bigger. To find the length of sinew to go around the drum, we have to estimate the circumference of a drum. And do you remember what the equation for circumference was? So it's C equals R or pi times D. And D is for diameter, and since we have diameter up there, we'll use that one. It's pi times 15. Remember to use the pi button in your calculator. And that's about 47.1239 inches. And again, keep as many decimals as you can to start with. Okay, Alishan uses 3.5 inches sinew for each inch of frame. Okay, and we got that from here. 3.5 inches of sinew for each inch of the frame. So now that we know the circumference of the drum, this is circumference of the drum. We know he needs about 3.5 inches of sinew per inch of drum. So if we want to know the length of the sinew, that's what we want. We know that the circumference is 47.1239. We know that per 1 inch, he uses, and this is inches too, 3.5 of the sinew. So you cross those off. 64.9. We'll round that up to 165 inches. Okay. And we want to give the answer in yards and inches. So I squared it too soon. We have to convert from yards to inches. So I move up here, and you can write underneath here if you want. So I'll go up here. So we have 165 inches. And I know that in 1 yard, there are 36 inches. So I get 4.583 yards. And just like in feet and inches, I'll put my answer down here. We have 4 yards. And now we have to find out what this means in inches. So we have 0.583 yards. And we know that in 1 yard, there are 36 inches. So if we do 0.583 multiplied by 36, we end up with 20.988, or 21 inches. So our answer ends up being 4 yards, 21 inches. Okay, and then your assignment is in the textbook, and I will scan that in, and I will also try to remember to scan in the photos that we used so that you can see them. Just hoping that would go to a different color. Okay, so do that assignment, and then just keep checking back regularly for the rest of the videos. Thank you.